This is 4.7, trigonometric inverses. An inverse function is a function that has its domain and range switched from the original function. So for a function to have an inverse, it has to be 1-to-1. And the test for 1-to-1 functions is the horizontal line test. And so what that would mean if I draw a straight line through the function, a horizontal line through the function, in order for this function that I have written here to have an inverse, it would only pass through one point. Well, you can see right here it fails it miserably. And so the sine function does not, as it's written, have an inverse function. Another example would be, say for instance, I had a parabola. All right, here's a parabola, and it passes the vertical line test. You know, if I draw a vertical line through, a quadratic or a parabola is a function because it passes the vertical line test. But when I draw a horizontal line, I can see that the inverse of this function is not going to be a function. So, for instance, if I find it, remember that you find an inverse by switching the domain and range, which in practicality means the x and y. So this particular function would look something like this. It would be sideways. And you can see that that's not a function. So instead, what we will have to do is we will have to do something called restricting the domain. So I'm going to write that on here, restrict the domain. In other words, we would say we're not going to use the whole graph. We're just going to use part of the graph. The part of the graph that we use is going to pass the horizontal line test. So you can see here, if we stay pretty close to the origin, and we restrict the sine graph between negative pi over 2 and pi over 2, then that little piece, this little piece of the sine graph, passes both the vertical line test, and it also passes, so it passes a vertical line, and it also passes the horizontal line, just the blue part, right? It's obvious that the whole sine function doesn't, but if we can restrict that domain so that we're only going to access between pi over 2, or negative pi over 2 and pi over 2, all right, between that domain, then we will have a function that we can find the inverse function. And so what we will talk about then is what that inverse function looks like. So you can see here that we have the inverse of sine, and so what I'm going to write is the function, if our function is sine x, then the inverse function will be arc sine x. Now there's another notation that you may have seen. This inverse, f inverse, the inverse of x, is going to be sine to the negative 1 power, but it's not the power, it's just notation, of x. These mean the same thing. So these are inverse functions of each other. So remember, to find the inverse of a function, you are exchanging or changing or switching the domain and range. So you notice that on the sine function, this right here was the y-axis. This is the y-axis of the sine function. And this was the x-axis of the sine function. Okay, and so for arcsine, we've switched those two, and so now the x of the arcsine is the y, and so that's why this is an inverse of the other. Right, so you'll notice now that this y-axis are now the angles, and the x-axis are the values. What was the domain is now the range. What is now the range is now the domain. Okay, so that's what this looks like. We're still going from 1 to -1, but we're going from negative pi over 2 to pi over 2. Just a quick recap here as to what we're doing. Up here we have the unit circle with the quadrantal angles on here. 0, pi over 2, pi, 3 pi over 2, 0, and 2 pi. And then I've drawn an XY graph that we use to graph sine, cosine, tangent, cosecant, all of those. And I've shown here that this is 0 radians, this is pi over 2 radians, 0 radians, pi over 2 radians. This on the other side is a negative pi over 2. Now this corresponds to the unit circle because this is 0 radians, this is pi over 2. What is this here? Well, I have 3 pi over 2 written, but it's also negative pi over 2, is it not? So this is also negative pi over 2. So what this is saying is from here to here, 0 to pi over 2 is the first quadrant, and from 0 to negative pi over 2 is the fourth quadrant. And that's how those correspond. So for the inverse, for arcsine, we are going to be looking for values in the first and fourth quadrants because that is our restricted domain. Okay, moving on to cosine x, we can see here that cosine is also an oscillating function, and its domain is from negative infinity to positive infinity. And so we're going to have to also restrict the domain of cosine. And remember, cosine is sinusoidal, just like sine is. So the domain restriction is going to look like this. We're going to restrict it between 0 and pi. So the restricted domain is going to be between 0 and pi. From 0 to pi. And so if you think about this from 0 to pi, that would be the first and second quadrant. Cosine is positive in the first and cosine is negative in the second. So we're restricting the domain to just 0 to pi. And on the next screen you'll see what the arc cosine graph looks like. Okay, so you can see here that once again for the inverse function, and you can also write this y equals cosine -1x. Notice that now the y-axis are the angles, the angle degrees in radians, right? Or angles in radians, sorry. And then this side here are the values. And notice that they're both positive. They're between 0 and pi, from 1 to -1. And so this is going to be from 0 to pi instead of negative pi over 2 to this. So these are different quadrants. This, once again, is the first and the second quadrant. Okay, here is the tangent and arctangent graphs. You can see that the tangent graph passes the vertical line test, so it is a function. It's a repeating function. It has asymptotes, remember, a period of pi, but it does not pass the horizontal line test. If you use the entire domain, the inverse of tangent is not a function. So to make it a function, once again, we are going to restrict the domain, and we will restrict the domain to between pi over 2, or negative pi over 2, and pi over 2. So we're keeping it right around the origin. We are just looking at this period, this pi period right here, either side of the origin. See the origin here. And then you can see this is what the graph looks like. Remember that the inverse switches the domain and range. And so what was the y-axis over here is now the x-axis. And what was the x-axis, the angles, is now the y-axis on the arc. So notice that tangent is centered on the origin. It is an odd function. It is an odd function, so is sine. These are odd functions. So sine and tangent are both odd functions centered at the origin. And so their inverse domain, or the restricted domain for the inverse, is both of those are going to be from negative pi over 2 to pi over 2. And so this is really important to remember when we get moving a little further here. So here's a recap of what we've got here. We know that if I have the square root of 2 over 2, a ratio, the square root of 2 over 2, it's equal to the sine of an angle, pi over 4. Okay? So that's a ratio. Or if I wrote it this way, if I said, what is the sine of pi over 3, then you would say that was the square root of 3 over 2. All right, the inverse of this would be an angle. The angle, pi over 4, is equal to the arc sine of the ratio, square root of 2 over 2. All right? Or I could say that pi over 3 is equal to the arc sine, notice the different notation, of square root of 3 over 2. Okay, on this slide you can see the unit circle with all the values on it, both radians and degrees. And then you can see also that I have listed the definitions of the inverse trig functions. Once again, saying the domain for arc sine is going to be from negative 1 to 1, and its range is going to be the first and the fourth quadrant. Notice that arc sine and arc tangent have the same range, both of the same quadrants. It's cosine, the even function, that is from 0 to pi. All right, so 0 to pi, cosine is first and second quadrant. From pi over 2 to negative pi over 2 is both sine and tangent, arc sine and arc tangent. Okay, so let's do a couple of problems. Let's say I want to find the arc sine of 1/2. All right, so the value is positive, and so it's sine. And so I know I'm in the first quadrant, so I'm going to look in this red quadrant here, and I am looking for a value in the y position. There it is, arc sine of 1/2 is equal to an angle, and so the angle at 1/2 is pi over 6. So the arc sine of 1/2 is pi over 6. All right, let's look at the negative. So arc sine of negative 1/2. Remember that our domain is restricted to the first or the fourth quadrant. So I have the arc sine of negative 1/2, right? And I look in the fourth quadrant. The fourth quadrant I see is here, and so it says 11 pi over 6. But that's not between pi over 2 and negative pi over 2. So instead of writing it with the positive, I will write it also with a negative. So that would be negative pi over 6, not 11 pi over 6. Okay, so let's go ahead and do an arc tangent. Arc tangent of the square root of 3 over 3 is going to be first quadrant. It'll be sine over cosine. And we remember the little thing that we use to remember this. There are 2 3's, so this is pi over 6. And the arc tangent then of negative square root of 3 over 3 will be in the fourth quadrant, not 11 pi over 6, but negative pi over 6. So you do sine, arc sine, and arc tangent the same way. Now the difference will be arc cosine. So if I can't erase, can I erase that? I can erase some of it. For cosine, I'm going to use the first and the second quadrant. First and second quadrant. So I have the arc cosine of square root of 2 over 2. So it's positive, the value's positive. I'm in the first quadrant. The angle with the cosine of square root of 2 over 2 is going to be pi over 4. So then if I have the arc cosine of negative square root of 2 over 2, I will be in the second quadrant. And the second quadrant, where cosine is negative, is this one. Now, the domain is from 0 to pi, so that means I can use this angle, and so this is going to be 3 pi over 4, not negative pi over 4. If it's negative pi over 4, it would be in this quadrant, and cosine is not negative, it's positive. So that's why we're in the second quadrant, for cosine only. Okay, one last thing. Using your graphing calculator, you can find the arc sine, arc cosine, arc tangent using your calculator. And the first thing you need to do is go to the mode button. That's what's on this screen. And then make sure that your calculator is in radians. Okay, so what we're going to do is use the calculator to calculate a value. And so what you're going to do, here is your, you notice here, here is your inverse tangent, inverse cosine, inverse sine buttons. All right, so if I want to find the inverse sine of it's going to be a ratio, right? So 0.5832. The answer is going to be an angle. Okay, and so that's going to equal 0.6227. Now, how on earth do you tell the difference? Well, you have to know that this is a ratio and this is an angle. And so if you take the second sine of 0.5832, then this is going to be 0.6227, which is an angle in the first quadrant in radians. And that's in radians because that's the mode you're in. Okay? Okay, let's do one more. Let's find the arc tangent of -6. Okay, so when I find the arc tangent of -6, I hit the second tangent, -6, hit enter, and I get -1.4056, which is an angle in the fourth quadrant using the negative aspect of it. Okay. Now, I want you to try this. Let's do the cosine inverse of -1/2. Okay, so second cosine, -1/2, gets me 2.094 radians. What quadrant is that in? Well, that's in the second quadrant. Now, it should also be equal to 2 pi over 3. And so if you do 2 times pi divided by 3, you get 2.094. So these are the same things. 2 pi over 3 and 2.094 are both in radians, and they are in the second quadrant. Okay, that's it for this lesson. I want you to try these as you're going through. Make sure you've taken good notes and be prepared for class. And we'll go over this again.